Okie dokie. So, it's now 10:40. We're going to start this class. I sure hope this works. So, this class, I'm hoping is going to be a programming class. Okay, I want to teach everyone how to program. I want to teach everyone how to work with Linux, how to work on supercomputers. I want to teach good programming habits and the tools that are available for programming in general. And then, of course, how to make your code go fast and all that other fun stuff. So I'm going to start with just an overview of Canvas. So here is the class stuff here on Canvas. And the home page is actually the syllabus, and it tells you that the syllabus is located in the Files tab over here. And then all recorded lectures are going to be found in the Panopto tab, which is all the way down at the bottom. Panopto is the recording software, so that's why it's called that. So if we go to Files, we can pull up the syllabus here. So this class is Tuesday, Wednesday, Thursday, 10:40 to 11:30, and it runs from May 10th to August 12th. So this is a full 14-week course. We may or may not fill that. So I don't know. I've never had to plan a course all on my own before. So course description, like I said, programming in Linux. C, C++, Fortran. Okay, that's what we're going to be using mostly. I will talk a little bit about other things like MATLAB, Python, etc. But mostly we're going to be talking about C, C++, or Fortran, whatever you're more comfortable with. And I'm comfortable with all three, so whatever you prefer. So we're going to be focusing on working with distributed computing systems. That's supercomputers. Yay, that's the fun stuff. Okay. Serial computing optimizations, and serial means when we're working with one processor and not multiple processors, which includes things like cache locality, and we'll talk about that. There's two parallel paradigms or systems that we're going to be using. Well, the first one is OpenMP, and the second one is MPI, and then we're going to, along with those, we're going to talk about algorithms, how we actually solve stuff in parallel so we get the correct answers. And that's what some of these are: wavefront methods, red-black methods, domain decomposition. And miscellaneous topics is everything that I've always wanted to tell people. So requirements, numerical methods, but we're going to keep those really simple in this class. Okay. And then programming with C, C++, or Fortran. We do have a book, and I forgot to bring it, but that's okay. We don't have a webcam here anyway. And it's Introduction to High Performance Computing for Scientists and Engineers. This is a book I used when I took this class like 5 years ago. And it's really cheap on Amazon, and I'm sure you can find a ripped PDF copy somewhere. So grading. So I will be having quizzes. These will be easy quizzes, I promise. I haven't figured out how to set those up on Canvas yet, but I'll figure that out this week at some point. And then the rest of it is going to be computer projects. Yeah. So everything in this class is basically going to be project-based. Okay, I'm going to have you write a code. You're going to submit it to me on Canvas. I have to be able to compile it and run it and get the correct answer. Okay. Along with that, you will need to submit plots and short paragraphs. I'm not looking for essays or papers. Plots. And I will grade your plots. They have to be nice. And I will grade your grammar. It has to be nice. Okay? But short paragraphs, not looking for anything too difficult. So again, all those will be done through Canvas. Lectures are recorded. Computer projects, again, no cheating. But I understand debugging. It's helpful to have a second pair of eyes or a third or fourth pair of eyes to look through your code and help you figure out what's going on. I am available for, help. This is a 5,000 or 6,000 level course. It can be difficult, especially trying to wrap your brain around how to think in parallel. It's not an easy task. So I'm available through email. My email address is on the top of the page here. I prefer to correspond through email than I do through Canvas. I don't like Canvas's messaging system very much. Okay, so as far as again, I've never had to plan a class before, so I don't know how long these things are actually going to take, but here's a general idea. So this week is going to be talking about Linux, how we use Linux, how we compile on Linux, and then on Thursday we're actually going to have a presentation done by the University of Utah on how to use their systems. Since they know them better than I do, I figured that would be a good thing. Next, we're going to talk about serial hardware benchmarking. We're going to see whose computer is the fastest. So pull out your laptops. If you could get it to run on your tablet, that would be a really cool comparison too. And we're going to talk about serial optimizations, how we actually write code that goes fast in the first place, not worrying about the parallel part. Then we're going to start talking about parallel benchmarks, and we're going to go into OpenMP. HE here stands for heat equation. So that's going to be our basic test case, is we're going to solve a 2D plate heat equation.
Just diffusion,
right? Right, it's just diffusion. It's a Laplace equation. It's super easy. And we're going to do that in OpenMP, and then we're going to do the same thing in MPI. Those are our two paradigms there. And then miscellaneous topics. We're going to talk about genetic algorithms, Monte Carlo methods. Genetic algorithms probably won't take that long, but I kind of was trying to fill up space. As you can see, we have a lot of space, and I don't know how long stuff is going to take. So if we finish early, we finish early. Last day of class is actually my birthday, so I expect presents. And so that is the basic syllabus there. So, as for today's lecture, I should note, I put a folder here with what I like to call useful PDFs. These are things that I've collected over the years, and I thought I would share with you. We've got stuff on Python, on Vim, on Doxygen, which I'll talk about later, OpenMP, Mercurial, MPI. This MPI book is actually the reference. You can find it in the library. I found it once. And, so it's actually the reference. MPI in Fortran, OpenMP, a document I found once on how to optimize C++ code. And then ProGit is a book on how to use Git, which I'm going to talk about tomorrow. So that's that. Now, as for today, today we're going to talk about Linux, what Linux is, and how it works. And there's this stupid bar in my way. Get over here. So I'm basically following this tutorial. The one below is the one that I learned from, but it's a little more technical. So it might be easier to go through the first one first. Hopefully my tutorial will be enough. Okay, and just so you know, my slides are mainly outlines for my talking and not really there for information purposes. But anyway, so before we learn what Linux is, we have to understand a lot about the rest of the computer. So I have this little pen thingy here. I think this might work. Ooh, I can draw. Cool. Okay, so let's say this is your computer. Okay, it's the actual physical hardware. And when you turn on your computer, there's a set of things that happens. The first thing that happens is the bootloader. The bootloader is software that's built into the motherboard. And this is the BIOS, it's the CMOS, the UEFI, Linux. There's another one called Grub. And what their job is to start the operating system. Okay? So these things, they start the operating system. And the operating system typically consists of what they call a kernel. So we're going to draw a kernel around our operating system. And I wonder if I can, okay. Okay. And the kernel is actually what does the heavy lifting. It interacts with the hardware. It contains the drivers. Everyone's probably had graphics drivers problems in their life at one point or another. Okay, that's an operating system problem. The operating system actually does not consist of what you see, okay, on the screen. It's everything that's hidden. Okay? It allows everything else to interact with the hardware, so they don't have to worry about the hardware. So the operating system worries about the hardware, everything else worries about the operating system. So the part that you see in Linux, okay, is called the shell. It's different in other ones. So then we have the shell. And the shell is what we call the terminal or the command line. Okay, in Windows it used to be DOS. DOS doesn't exist anymore, but kind of the same idea. SH is kind of the granddaddy of all shells, but the most common one is bash. It stands for Born Again Shell. I don't know why, but that's what it stands for. And then on top of that, we have the GUI. So this is the fancy pictures, the nice stuff, okay? And so this GUI in Linux can be many different things, and we'll get to that. But, so I wanted to also cover a little bit of history of operating systems. I'm not an expert in any of this, just so you know. This is just stuff that I've picked up over the years. But so, long time ago, 1950s, 1960s, somewhere back in there, there were lots of companies trying to develop operating systems for these newfangled computer things. And Unix, I believe, was developed by Bell Laboratories, also now known as AT&T, if I remember correctly. And Unix kind of became the big wig in operating systems. There was Cray, they kind of had their own thing, and all the computer manufacturers made their own, but Unix wanted to make one that worked for everything. A little while later, we had Bill Gates, who started his DOS, MS-DOS operating system, and we had Steve Jobs, who started the Apple operating systems, and they all kind of grew up together. And so we kind of had Unix, who's back here, and then we had DOS and Windows. So we'll just put a big W there. And we had the Mac. And then off to the side, we had Linux. Okay, and there's a few more. There's FreeBSD, and actually there's dozens more. But these are kind of the big ones. They all started all at the same time. And they all had slightly different philosophies. So Windows was completely separate. It had nothing to do with Unix. Apple's operating system and Linux were both based on Unix. Windows has a philosophy of everything is self-contained. I will control everything. Okay. Mac sort of turned into that in the end as well. Linux was very much like, I'm going to let you do whatever the heck you want. You can shoot yourself in the foot, and I don't care. Okay. And of course, Windows and Mac, they were sold for profit. Linux was actually started as a fun project. It became a really big fun project, apparently. So the Linux as we call it, is actually the kernel. Okay, so it's the innermost part. And then other people ended up wrapping things around it. Okay, they wrapped the shell around it. They wrapped the GUIs around it. And so we have lots of what we call Linux flavors. Okay, there's some free versions. There's some commercial versions. So there's Debian. Debian is definitely kind of the biggest of them all. Okay, Ubuntu is based on Debian. Mint is based on Ubuntu. Okay, so we have this thing going on here. Then there's some other ones that aren't related to the Debian branch, as some people call it. There's CentOS, which I believe is what the CHPC cluster uses, and it's what our cluster uses. And then there's some other ones. There's Fedora, there's OpenSUSE, and I'm not sure what their relationship is because I've always stuck with the Debian side of things. There's a couple commercial versions. Red Hat Enterprise is a paid-for version of CentOS. SUSE is a paid-for version of OpenSUSE. Now, I'm just talking about this layer here, okay? So that is that layer, basically. And then we have GUIs on top of that. So we have XFCE, GNOME 2, GNOME 3, Unity, LXDE, KDE, Mate, Cinnamon, and that's only to name a few. And they all look different, they all act different, and some of them suck and some of them don't. And most of the flavors up here have a default version that usually works really well, and that's generally what I stick to. But you can see why people don't like Linux. It's confusing, it's a mess, because everybody has their own ideas on how to do things and whatnot. So my personal favorite is Linux Mint, with the default GNOME 2 Mate interface. So Mate is based on GNOME 2. So it's actually Mate. I should probably come back here, that one. So I like the Mint with the Mate, and it reminds me of Windows 95 and how wonderful that was once upon a time. So that's really taking it back. But it's prettier than Windows 95. Okay, I'll say that. But it still flows the same way, and I like that. I should say Ubuntu is the biggest. It's the most widely supported. It's the most widely used. So Ubuntu is also a good one to use to get started with. So if you want to get Linux, the first thing you have to do is get the ISO file. Okay, if you go to DistroWatch, they actually list hundreds of Linux distributions. And they list the most popular ones and where to get them and all that other fun stuff. So once you get that, then you can create a live CD or a live USB. This is just a thing that you can stick in your computer. You reboot your computer. It boots from the CD. You install. Okay, it's really simple. And if you get a mature distribution like Ubuntu or Debian or Mint, they're seamless. It's better than Windows installations for sure. So if you want to install this on a computer, you can do it using a virtual machine. You can try and dual boot your computer, which is harder now because of the Windows 8, Windows 10. They changed things, how that works. And I've only tried it once and it didn't work. Or you can do a clean install, which is you wipe everything on your computer and you just have Linux. What you don't want to do is install Linux and then try and install Windows, because Windows does not play nice with Linux. So you install Windows on your computer, then you can install Linux. Personally, I like the virtual machine route because you get access to everything. There are a few alternatives on Windows. The first one is called MenGW. And this is a set of programs that are actually compiled for Windows, and they work on Windows that behave similar to a Linux environment. The next one is Cygwin, and it's kind of like a terminal virtual machine-ish, where it actually takes your Linux commands and turns them into Windows commands. And so it's weird. And I haven't had too much success with it. And then the other one is PuTTY. And PuTTY is actually a terminal that lets you log into a remote Linux machine like the cluster. So if you don't want to deal with any of it, just get PuTTY and log into the cluster and do everything there. Okay, but the cluster will be in Linux, so you'll need that. If you're using a Mac, it's based on Unix. They do pretty much the same thing. I'm not familiar with Macs. I've never been rich enough to own one. So I can't help you too much there, but there should be good documentation out there if you want to do that. So let's see here. Can we? No. So I have asked on this machine to have. Come on, where are you? So I have a virtual machine installed on here. And we've already installed Linux Mint on the virtual machine. This is called VirtualBox. It's pretty slick. It works really well. So we make the little bubbles go away. Okay, so we log in.
What are you logging into?
So the way a virtual machine works is it actually tricks the operating system into thinking that it is a computer. So this virtual machine acts as if it were a real machine. And the operating system doesn't know the difference. Does that make sense?
So you can access files on your computer up there is from a Linux stand?
No, this is self-contained on this computer. I'm running an operating system inside of another operating system, basically.
What I'm saying is you can access the files on that computer through that virtual machine.
Actually, I can't.
Oh, you can't?
The virtual machine sets aside a piece of the hard drive that is just for that operating system.
So there's nothing on there?
There is, well, currently there's nothing, yes. And does that make sense to everyone, how that works? Okay. I found it really handy and slick. So we're going to talk about the terminal. So let me see here. What's our next slide? Did I go to the next slide? There we go. So the terminal. This is just a text-based interface to the system. Okay? Its job is to interpret your commands to run other programs. So it's a program that runs other programs depending on what you tell it. And Linux is based on a building block philosophy. Every command you type is a completely separate program. And then through the terminal, you tie those together to make more complicated systems. Okay? And you tie them together using what they call pipes. So, for instance, in my terminal here, can I make this bigger? No. Did I install this? I did. Good. Now I can make it bigger, right? Maybe not. I thought I could make this bigger so everyone could see it. There we go. Okay, is that big enough? Too small? Turn this off. Is that better? Okay, so in the terminal, I can type a command, and it does something. So let me go back to our slide here. So the first thing I want to do is talk about the directory structure. So directory is another word for folder, if you're more familiar with Windows. And in the terminal, it's going to, the very first thing you see here, it's actually telling me my name, so this is my username, at the computer's name. Okay, this is where the @ symbol basically comes from. And then it gives me this little cursor here. And the first thing I want to show you is PWD. This stands for Print Working Directory. It tells me where I am located in the directory structure. So currently I am at /home/mint-admin. Okay, so, right, okay. So the directory structure in Linux always starts with this slash. This is what they call the root directory. This is the base of your file system. And you'll see by typing ls, which stands for list, it lists all of the folders and files in the root directory. And we have a special folder called home. And so I can use cd, which stands for change directory, to move into the home directory. In there, we see mint-admin, which is the name of it's my username. And so inside of here is where all of my files are going to go. Okay, I own everything in here, and I can change it and manipulate it and whatnot. You'll also notice that before I had, in the blue text here, I had a slash that told me the current directory, a /home that told me I was now in the home directory. Now I have a tilde. And the tilde basically is a shortcut for my home directory. Okay, no one else's, just mine. And so in the blue, it should tell you kind of where you're at. But if it doesn't, you can always use the PWD. Oops, that's the wrong button. Okay. Command line arguments. Okay. So another thing, every command in Unix generally accepts some sort of command line arguments. And these are flags. Some people call them flags. Generally, they start with a dash and then either a single letter, which is called a short form, or a full word or set of words that is called the long command. And whichever one you use is kind of a personal preference. So when you're using the list command and you pass it a -a, you'll notice we have a lot more files. And these files are the dot files. And these are hidden. If you start a file with a dot, the system considers it hidden. And so by default, it doesn't show it unless you specifically tell it to by using the -a flag. Some other ones we can use is -a-l. Okay, the L stands for long. So I could also use -a --. Long commands almost always start with a --. Can't type. Okay, I was wrong. There is no -- long command. I didn't know that. Anyway, so this stands for long. It lists a whole lot of information about it. This is your permissions. I don't even know what this number is. This is the owner. This is the group. This is the file size. This is the date it was last modified. Okay, so there's some good information there. And we'll talk about each one of those pieces later.
For ls, can you do -al to do both instead of separation?
And then short commands can be changed together. And it does the same thing. It didn't look any. There's a good command for you. Reset. Just makes everything go away. Yeah, so you can chain them together in a shorthand form. Okay, so next, paths. We need to talk about paths. And we're running out of time. So, a path is a location in the directory structure. Okay, so if we type PWD, what it does is it gives us the path, the absolute path, starting from the root directory all the way to where we are currently located. Okay, now there are such things as relative paths. So let's see here. Let's skip ahead. Let's see here. So cd, change directory, we can move to downloads. And this is actually a relative path. It's relative based on where we are at. However, I could type that. That would be the absolute path. And it would give us the same result. Okay, it kind of depends on your situation, what you're more comfortable with. And if we do an ls, we see there's nothing in the downloads folder. Now, the very important thing here, a dot dot stands for the directory above this one. Okay, this is a tree-like structure. Everything is contained somewhere. And so if you use a dot dot, it's referencing the directory up above you. So I could change directory back to the home directory like that. Oops. Okay, another trick, handy little trick, just so everyone knows. If you push tab, it'll give you a list of possible options. And okay, so now we're there. And once it's unique, the tab will complete. It's called tab completion. It's a wonderful thing. It saves you a bunch of typing and typos. Because the computer's good at spelling and you aren't. So if I wanted to change to the desktop folder without, in a single command, without having to go back and then go forward, you can use the dot dot command, or path specifier, not command, to specify you want to go up one tree and then back down into desktop. Okay. So that put us back in our home directory in the desktop folder. Okay. Another important thing to note. Everything in Linux is a file. Your screen is a file. Your keyboard is a file. Okay? The directories are actually files. Okay? All they do is contain a list of everything contained inside of them. That's all they are. Also, there are no extensions. So if you're coming from a Windows, and maybe Mac, I'm not too familiar with that, but if you're coming from Windows, the extensions mean something. Okay, if you put a .txt on your Windows file, it will try and open it with Notepad. Okay? If you change that to .exe, it will try and run it, and it will fail. Because the extensions mean something. In Linux, they don't mean anything. The operating system will actually read the file, figure out what kind it is, and then run the appropriate program. Okay? So it's what they call extensionless. So if I had a file, let's call this, okay, and if we open up blah.txt, and we're going to type hello world. Okay. Now, I put that on the desktop, so we should be able to see it here. Okay, so there it is. And it knows that this is a text file. Because I put .txt, maybe. A lot of the newer Linux distributions do try and take the extension into account. So let's close this. And now we're going to change the file extension to if we look at it, now it's going to tell us that this is a .exe file, and it changed the icon. That's the operating system trying to be helpful and basing things off of this. And if we try and open it, well, it doesn't like it much. You'll see it didn't really do anything because the operating system is trying to be helpful. But if we open it in the terminal, if we open it with a text editor program, the text editor doesn't care. It's going to try and read it as a text file. Okay? Which it happens to be. So that's just some important things to note. You actually don't even need an extension. Okay, so what happens if we take the extension off? Now the operating system has stopped trying to be helpful, okay? Because it doesn't know, it doesn't have an extension. And so now it's going to actually read the thing and realize, hey, you're a text file. Okay, does that make sense? Another important thing to note, everything is case sensitive. Okay? Windows is not. And then we've actually run into problems with that before, but everything is case sensitive. Important rule of thumb, don't put spaces in your file names, ever. Okay, if you want a space, use a dash or an underscore. Or you could use what they call a camel case, where you capitalize the beginning of every word. It's called camel case. Some people really like it. I don't, but and there's reasons for that, because the terminal, as you see, how are we separating out all of our words? Spaces. We're using spaces to separate. So what if there's a space in your file name? How is the terminal going to know about that? Right, you have to put it in quotes. So we're going to move blah to blah 2. Okay? And now if we try and open up blah 2, you'll notice the tab completion quite nicely put that little / / whichever one. It's the one above the enter key. Okay, and that tells the file system, hey, this file name is still going. Okay? Or you can do this. Put it in quotes. And now it puts the whole thing in quotes with no file extension or no slashy thing. Okay?
You should have just said it doesn't work if you try and put a space in the file.
It just makes it harder. So don't do it. Okay? Okay, so let's go to the next slide. So we now want to manipulate this file system, and I'm going to go through this pretty quickly because there's not much new here. We can type mkdir, which stands for make directory, and this program makes a directory, and all we have to do is give it a name. So we'll call it, okay, and now we have a file right here called Trogdor, or directory. So that's simple. There's a very kind of handy flag here called the P, which will actually create a whole hierarchy of directories. Okay, so okay, so now we have Trogdor 2 with a troglet who's eating a peasant. Okay. If we try to do the same thing without the P, cross your fingers, it shouldn't work. But it does work because it's actually there. So now I changed it to Troglet 2. It says it can't make that because Troglet 2 does not exist already. But with the P flag, it makes everything that it needs to. So that's kind of handy. So almost every single Unix command has a -v flag, which stands for verbose. And it will tell you what's going on. Okay? So here it's created, it tells us, hey, I created this directory. Okay, and if you are making a whole slew of them, it will tell you, oh, I made this one, oh, I made that one, and that one. Verbose is usually, you don't usually need it, but it's handy to know if you need something, if you need to debug what's going on. Okay, so we can create a blank file. It's literally a file that has nothing in it with the touch command. I don't want to activate Windows. Why are you there? So the touch command, all it does is makes a file. There's nothing in it, but it sets aside space on your hard drive and says, here's a file. So that can be handy. Copying a file with the cp command. Okay, so we can copy hello to hello 2. If we do ls, it tells us now there's a hello 2. Now let's try and copy Trogdor to, okay, good point. Got to get rid of hello. Okay, and it's going to tell us it's omitting the directory Trogdor. Okay, Unix commands as a safety measure do not work on directories unless you explicitly tell them to. Okay, and that is the R command. It stands for recursive. It means go into the directory, copy everything, then copy the directory. Okay? And so now we should have a Burninator directory. So the -R is used in many commands. It's generally available. Okay, we can move a file. So let's say we want to move hello. We can move it up. Okay, we're going to move it up to my home directory. And you'll see if we do an ls, there is no more hello. But if we do ls ... there it is. Okay, we've moved it. This is also how you rename a file. So we can move hello to Adele. Okay, and we didn't specify a directory to move it to. All we did was say change its name, basically. Okay. And then, last but not least, the remove command. Okay. So if we want to delete a file, we use the remove command. Now, it's very important you realize that there is no undo button here. Okay? Because this is not operating through the system file manager. If we open it up here, the operating system has its own little file manager. And if we delete this like that, we can now hopefully undo that. Okay? That's because this is a convenience provided by the operating system, by the file manager. They have a little trash folder that if you delete stuff, it goes into the trash, and it can pull it back out. But in terminal land, there is no undo button. So you have to be very careful with this. Also, as a safety measure, you cannot delete directories. Okay, if you want to delete the directory, you have to use the -R flag. Okay, again, no undo. It'll delete everything. I once deleted my entire computer. That's not good. And in fact, I wanted to share this little story that popped up last month. So can I click on this? This stupid PowerPoint. I'll just... Marco Marsala appears to have deleted his entire company with one mistaken piece of code. Okay? The problem command was rm-rf. Okay, the F stands for force. There are certain situations where it will stop and say, I can't delete this unless you specify the force command. Okay, the force flag. A basic piece of code that will delete everything it is told to. Okay? Together, the code deleted everything on the computer, including his customers' websites. He runs a web hosting company, or at least he ran a web hosting company. He has 1,500 customers, Last night, I accidentally ran on all servers a bash script with rm-rf with the variables foo and bar. Okay, I don't know why they use foobar in Linux land, but they love foobar for whatever reason. So don't be confused by those. They're just examples. Anyway, these variables were not defined. They had no names attached to them, and so he ended up deleting everything, including all of his backups. So just be careful. Yes, and that's exactly what I did. I thought I was in a folder when I was actually in my root, and I ran rm-rf trying to delete everything in that folder, but I was in root, and so I ended up deleting my whole computer. And I was sitting there, I was like, why is this taking so long? Yeah, that was a bad idea. And thankfully, I didn't delete my backups. So, okay, we are almost out of time, but I think this is, yeah, we'll have to continue tomorrow. I want to show you Linux by default, not by default, but has the man pages, as they call them, the manual pages. And they give you information on commands. So if I want to understand what ls does, how it works, what flags it takes, you type man ls, and it pulls up this page, which you can then scroll up and down and read everything about. It takes a lot of flags. A lot of flags. Generally, you don't need those flags. Okay? But if you ever want to know anything about Linux, it's in here. And generally, they are terse, they are technical, they are difficult to understand. But I've found Googling things helps with that. Okay? So there's the man pages. Oops. Long, short command options, we already covered that. Wildcards. Okay. So the shell, the bash shell, actually has special characters. So if I wanted to remove, with the -r flag, all the folders called Trogdor, you see I could list them like this, Trogdor and Trogdor2. Or I could just say Trogdor star. The star is what they call a globbing character. It basically says match anything that says Trogdor and anything after that. Doesn't matter what it is, just match it. And the shell itself will take that star, find everything that matches it, and expand it out to this. At which point it then feeds those to the remove command. So the remove command has no idea that there's a star. Okay? It's just a convenience offered by the bash shell. I always forget that doesn't work. So the star matches 0 or more characters. The question mark matches a single character. Doesn't matter what it is. It just matches a single character. The brackets, if you put characters inside of a brackets, the square brackets, it will match anything you put inside of it. Okay? So those,
Can you give us an example?
yes. So am I running out of things to delete? So let's make a couple. Okay, so I can, if I do a question mark, the echo command just prints things out, so it's kind of useful to see what's going on. The question mark matches 1, 2, or 3, a single character. Okay, the star matches 1, 2, or 3. In fact, let's run those two commands. Also, up and down arrows scroll through your command history, so that's really helpful. So if I echo blah star, you'll notice I get the blah with no number, and then all the numbers. But if I do the question mark has to match a single character. And since there's no character, we don't get just the blah. And then if I wanted to match 2 and 3, like that.
So those inside the brackets have to be numbers. Or, oh no, they just, oh okay.
Just have to be some sort of characters.
They can be any
Yeah. You can also do this 0 through 9. Okay. Or you could do A through Z, lowercase A through Z. And then you could do uppercase A through Z. And then 0 through 9.
And does that only work, like, so inside those brackets only accounts for a single character?
Exactly.
Okay.
So if I had like them all listed through 100 and I wanted to do like 20 through 30, I would do a bracket 2 through 3 and then a second bracket 0 through 9.
Yes. Or you could do this.
Okay.
Okay. So, anywho's so that's very, very useful to know. And we are out of time, so I will continue with file permissions tomorrow. But if you have any questions, you're welcome to ask me. I mean, no one's coming in here, right? It's summer. Okie dokie. Well, thanks for coming to class. There won't be a quiz on this yet. I'll probably set one up, just some basic, how do you do this? How do you do that? It'll be a simple quiz. But if you want help setting up your own Linux stuff, let me know. And yeah, anyway, thanks for coming.